Okay, welcome to my third video. This is an actual homework problem from tonight's homework. It's on page 359, question number 9. If you will look up at the top here, you will see the two problems that are involved in kind of a skeleton form, which helps your mind focus a little bit, even better than sometimes the given and find. And so our first problem up above in this blue block is the first thing we're trying to do is change moles of SO2 to moles of H2SO4. And then in the second problem, we're asked to change SO2 into oxygen. I'm going to move a little bit faster on this one because I'm trying to get a lot in a short period of time here. Let's go to the balanced equation, though. That's the one that's probably going to give you most of the problem. And this is a word problem in the textbook, and you might have a tough time interpreting this particular equation. So I went ahead and worked it out for you so that you got sulfur dioxide and oxygen and water going to H2SO4. Now, you'll notice that I have oxygens here, 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 and here. That spells trouble if I'm trying to balance oxygens. You will take forever balancing this if you try to balance your oxygens. So let's look and see if there's something that might go wrong in the balancing that I could fix, because all the individual kinds of atoms are in balance, so to speak, except the oxygen. So I got to look for something else I could fix. Well, here oxygens are even. Is there anywhere on the left where oxygens are odd? Yeah, the H2O, this little bugger right here. So what's the smallest number I could multiply them by to make an even? 2. Okay, so let's give them a 2. Now, let's check everything out and see if that simple little thing was able to get the whole thing balanced. Did I mess anything up? What got messed up? Okay, the hydrogens got messed up. I have 2 on the right, and on the left, because of this 2, I've got 4 hydrogens. Yeah, we can multiply our sulfuric acid by 2. Now let's see if we're totally in balance. Sulfur, check them out. 1 and 1. Okay. Hydrogen. Hydrogen's right here. How many? 4. And over here, 4. That's what we did originally to try and get hydrogens even, right? Now let's check out our oxygens. We got 4 here times 2 is 8. Yes? It is 2. Yes, it is. So let's go ahead and fix that. Thank you. You saw something I didn't see. Excellent. Okay, this sulfur is 2 because of this coefficient. And this sulfur over here was only 1, so yeah, you need that coefficient. Great. Okay, now let's look at oxygens. We're 8, and if you like, you may go. I'm going to continue the video. Please be as quiet as possible. So the sulfur is good. Let's check our oxygens out now. We have 8 oxygens because this oxygen here is multiplied by 2 as a coefficient. And the sulfur on the left, or the oxygens on the left, are going to be 4 here plus 2 here is 6 plus 2 here, which is 8. And our oxygens are balanced, and we're good to go. Now we can solve the problem. So let's go ahead and move on down the line and solve our first question. Our first question was to find the sulfuric acid moles. So we're going to start with the given, 12.5 moles of sulfur dioxide over 1. See, this is just like our example problem number 1, only it's twice as much. Now we're going to take and get the ratio that we need to get to sulfuric acid. Sulfuric acid is 2, and sulfur dioxide is 2. So we need to put that in over here. And the bottom of this has to be the same as the top of this, which is moles of SO2. And when we get that down there, what are we going to have on top? We're going to have the moles of sulfuric acid, which is what we're asked to find in this second one, H2SO4. And now we take the numbers from the coefficients and we put them down here because that's our mole ratio. So we have just changed the sulfuric acid, and this is going to be really easy because the 2's are going to be able to cross out, and so it's essentially 12.5. And that is moles of sulfur dioxide. So that's our first one. Now the second one is just almost as easy. 12.5 moles of SO2 over 1. Only this time the mole ratio is different. We're trying to get sulfur dioxide, this guy, to oxygen, and that's O2, and that's this guy right here. So let's go on down and get our mole ratio set up. The bottom has to be moles of SO2. It does indeed. And on the top, what are we going to have? We're going to have our moles of O2. And now we go to our balanced equation to get the numbers to go out front. This guy is going to need the 2 from here, okay? And the O2 up here, this guy is going to be a 1, so that's what goes up there. And now we have a simple division problem. See, the moles here cancel out with the moles here, and I didn't do that up at the first problem, but it's the same deal there. And so in the second problem, instead of just carrying this number over into our answer, we have to divide by 2. And when we do that, we get 6.25. Yeah. So this is going to be 6.25 is our moles of O2. Oops, I just wrote the wrong thing there. Let's get that fixed. Moles of O2. And now we've got ourselves the answer there, and let's circle that up, and we've done that problem. And that's how these kind of problems are worked out. Hope you got something out of this. Thanks for watching. See you in class soon.